Um, Concerning the multivariate function that Professor Shaibu taught us yesterday morning, yes. And many of us were not in class, many of us did not understand, only few people understand it. I'll be trying to break it down for us. That's the total derivative and the partial derivative, the multivariate function. So basically, what is this all about? In this topic, we are still going to be working on this on the so-called differentiation. We are still going to be using the concept of differentiation to solve this. So um, from the textbook, we start from page 43 to start to solve this on page 43. So it said a multivariate function. Let me just, a multivariate function is of the form y equals function of x1 x2 comma dot 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 comma xn. Now, what does this mean? This means that y is a function of different variables. Now, the reason why this heading is going with the multivariate function is because it has more than one variable. A multivariable, like when they say a multimillionaire is not somebody that has 1 million. He has like 10 million, 20 million, 30 million, 40 million of what. It's not just 1 million. Now, so the same thing here, a multivariate, you can just say a multivariable. Now, y is what is a function of what x1, x2, x3, x4, x5 to whatever number it is. This x here, this x1, this one here, and this two here, and whatever it is, does not have any significant impact on this equation. It's just to like indicate or differentiate a particular variable from the other. You get, just to differentiate a particular separate a particular variable from the other, so you will not mix the variables together. So y is a function of what, how many, a lot of variables. Once the variable is more than one, we are already dealing with a multivariable, that's a multivariate, and we can use the total derivative or the partial derivative to solve it. I'll try to make this quick though. Now, using the total derivative, now we have this what is it called, this function here, and for us, prof told us already that every function is gotten from economic theory, from theories, sorry. Function is gotten from theories, and theories lead to functions, while function leads to what, models. So now we've gotten the function. Now it's time for us to derive the model from this function. And what is the model? Differentiating y, that's the y equals what, the y dx. Sorry, please don't forget, Rema, you especially, don't forget that this d is going to be what, slant this time around. The y over the x. Now the x this time is what, x1. I'll explain why this is in a short, in a bit, sorry. So the x1 plus the y over the x2, the x2 plus y over x and the xn. Now, how do we arrive at this? The main the main difference in total derivative and partial derivative is what, when you are differentiating in total derivative, you are differentiating every variable together in addition with each other. Let me I think when I get to partial derivative, we'll understand this better. But for now, let's just continue this way. So the total derivative is what, the y equals to what, the u dx times the x1 plus the y, the x2 times what? The x2 plus this dot 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 here is Prof. Shaibu told us already that when you have something like this, these three dots, it means what? We have an infinite number of this thing there, depending on how many variables you want. It could be more than one, two, three, four, five, six, different, whatever the amount of variable they give to us to do. But the main thing you should just understand here is that this is a multivariable and it's going to contain more than one variable. So you say let's narrow it down now. Let's say we are dealing with two variables. If y equals to what? Function of x1 and x2. Now, how many variables do we have here? We have what? Two variables, two dependent variables. That is x1 and x2. These are the two variables. Now, y is a function of what? X1 and x2. This x1 and x2 could be anything. It could be, let's say this is quantity demanded. This x1 will not be what? Price and whatever it is. So the functions of this x1 are what? Basically the factors that affect y. So if y is quantity demanded, this x will be what? Factors that affect quantity demand. Sorry, this y, this x1 and x2 will be what? The factors that affect demand. And what are the factors that affect the most one? The most important one is what? Price. So this could be price or any other thing. So in order for us, this we have derived this function now, and in order for us to get the module, what do? Dy equals what? The y over the x1, not the x1 times what? The x plus the y over the x2 times what? The x2, sorry, let me take it, the x2. Now, this simply means what? How do we arrive at this? We, what we just did here was to what? Differentiate y in respect to what? To x. Differentiating y in respect to x. That's how we have what? The y over what? It's the x1 times what? The x. This is just the standard model for this. The y over the x1 times what? The x plus the y over the x2 times the x. Do you understand? Now, if we are dealing with partial variables, let me just explain this on chart. With a partial derivative, sorry. We are dealing with partial derivative. If we are given something, let me check for a question for partial derivative. Now, let's use the one that Prof gave us as example. Let's say they give us okay, let me find another one before we get to that. Okay, let's use this as an example now. Let's say they give us y equals to function of what? X1 comma x2, and they say y equals to what? 14 x1 raised to power 2 plus 8x1 8x2 plus 9x4. Yeah. Now, what does this mean? From the function they gave us here, they are trying to tell us what? That we have only two variables. That y is a function of what? Two variables. And that's what we have in this place too. Bringing it, expanding it, we have what? Y equals to 14x squared plus 8x, 14, sorry, let me start over. Y equals to 14x1 raised to power 2. That's this x1 raised to power 2. And I remember I said this one does not really have anything to do with the equation. It's just to differentiate 1 from 2 so that you will not get the two mixed up when you get their values. So 14x1 raised to power 2 plus 8x1 8x1 x2 Note that these two are together. These two are together. This simply means 8x1 times x2 plus 9x2 raised to the power 2. Now, if this was total derivative, what we would have just done is what? The y, that is the y equals the y the x times dx and so on like that. We would have done it this way. But because this is a partial derivative, what are we going to do? We are going to differentiate it one by one. The main difference between partial derivative and total derivative is that in total derivative, you are differentiating them together. But in partial derivative, we are going to differentiate them one by one. What does this mean? This means that when they say we should differentiate, when we want to get the derivative of this one, what do? We do the y, sorry, the y over a Jesus. That's what I was saying. Because this is partial derivative, we first solve for the first variable, that is x1. So it's going to be dy dx, dy dx1 equals to what? We're going to differentiate only those ones that have x1. Only those ones that have x1. We'll leave the rest. We'll leave the rest alone. So what are we going to do? It's going to be what? Differentiating 14x raised power 2 is going to be what? 2 times 14x raised power 2 minus 1 plus this one is going to be 8. I'm sure we know why. 8x raised power 2 plus, we are not, anyway you see the one that does not have this thing, that does not have x raised power 1, will turn it towards 0. Now, in case this is confusing, let me re-explain it again. We are, like I said earlier, in partial derivative, we are going to differentiate only the ones that we will differentiate the variables with one by one. Unlike this one where everything is going to be in one equation, this one we are going to differentiate them one by one. So that means if we are going to differentiate the first variable, what are we going to do? It's going to be the y over the x. That is the y in respect to what the first variable. That's what the x1. Sorry, the y in respect to the first variable. That is the x1. So equals to what? And you will now look for anyone that have x1. That's why this one and 2 that you see here is very important, so that you will not mix it up. So you look for the one that have what? X1. That's the one you will differentiate. So it's going to be, normally you have to bring your 2 to the front, multiply it here. That's 2 times what? 14 raised to power 2 times 14 raised to power 2 minus 1. 2 minus 1. Then here we have what? Remember I said these two together. That is 8x1. That is 8x2. 8x1 x2. What do we do to this one? We just differentiate for x1 alone. Remember, is this 8 is for both of these two variables. This 8 is for both of the two is for both variables. Sorry, it's for both variables. So it's going to be, we are going to differentiate only this x1. Remember, we are dealing with what? The first variable. We're going to differentiate only this x1 and leave this one like this. Now that's why we got 8x. Remember that there's no any the power here is just 1. So when we differentiate a variable that does not have power greater than 1, it becomes what? That same variable. So that's how we got this 8. And this x2 is not living because we are not differentiating x2. We are differentiating only x1. That's why we have 8x2 here, because we differentiated 8x1. You can check from your textbook, page 47. To try and follow me up, page 46, sorry. To try and follow me. Then 9x squared. Remember I said we are differentiating only x1. So what happens to this 9x squared? We treat it as a constant. And you know that constant is what? When you differentiate a constant, it gives you what? 0. So this one is going to be what? 0. This one is going to be 0. I hope you understand. Let me brush through it again. 14x raised to power 2. When you differentiate this, we are dealing with what? The first variable, x1 alone. So it's going to be 2x plus 2x, 2 times 14, sorry, 2 times 14 raised to power 2 minus 1. That's what we'll talk about that later. Then x, then plus 8x is more like saying, this 8x is more like saying, that is more like saying 8 times x1, 8 times x2. So it's both of these variables that have this 8. It's not just x1 that have 8. So what do? We differentiate only x1 in this equation, in this yeah, is the equation we call it. We differentiate only x1. And when we differentiate x1, it leaves there. We have only 8. So this x2 is going to remain. That's going to be 8x2. Then 9x2 raised to power 2. Because there's no x1 here, we are going to treat it as a constant. And that's how it turns to 0. Same thing goes for when we are getting the um what's the name? Second variable. So it's going to what? dy over the x2, dy over the x2 equals what? Now we are going to differentiate only those ones that have what? X2. And this x2, this one has only x1, no x2. What do we do to it? We treat it as a constant. That's going to be what? 0 plus, I hope you get it now, plus this one 8x1. Remember this before we differentiated only x1, we left x2. So this time we are differentiating for the second variable, which is x2. What do we do now? We differentiate x2, and differentiating x2, that means that one will leave there. It will now be remaining what? 8x1, 8x1 plus the last time we treated this one as constant, but this time we are getting for the second variable. So this one is going to be what? 2 times 9 x raised to power 2 minus 1. So that's going to be what? 8x1 plus 2 times 9, 18x raised to power 1. You can leave that one like that. And for this one, you can do this one by itself. That's 2 times 14, that's what? 28. 28x plus 8x2. I hope you get it now. Okay, I will make the next video trying to explain that ones that we don't understand. I just wanted us to understand the difference between total variable, total derivative, and partial derivative. In total derivative, we are differentiating everything at once. But in partial derivative, what we are differentiating each variable one by one on its own. That's the main difference